buenos días a todos. Muchas gracias por acompañarnos en la sesión de hoy. Mi nombre es Pedro Alcalá, director general de AMEXICCOR, la primera asociación de proveedores de la industria del cartón corrugado en México. Y me da mucho gusto nuevamente estar en estas sesiones de capacitación técnica de nuestro programa de capacitación técnica para la industria del cartón corrugado. Como saben, nuestra razón de ser es generar valor para la industria del cartón corrugado a partir de capacitaciones técnicas de alta especialidad y actividades también de networking. Recuerden que pueden consultar nuestros próximos eventos en nuestra página www.amexiccor.org, así como nuestras redes sociales, en donde también nos encontrarán como AMEXICCOR, en Facebook, LinkedIn y en Twitter también. Con el apoyo de nuestros socios como Central National, les traemos estas capacitaciones técnicas que hoy abordan el tema de diseñando cajas de cartón, cajas de larga duración con enfoque en materia prima. Gracias a todos los especialistas de la industria que se dan cita hoy para contribuir a construir una industria del cartón altamente competitiva y en mejora constante. Ahora cederé la palabra a Norma Arteaga, Senior Packaging Sales Manager para Central National Gottesman, quien como coanfitrión nos presentará a nuestros expositores de hoy. Muchas gracias por su participación. Norma.
Gracias a la AMEXICCOR por este foro tan innovador. Gracias a nuestros socios comerciales Mondi por el apoyo técnico y educativo. Mi nombre es Norma Arteaga, soy gerente comercial de papeles de empaque para Central Nacional Gottesman. Sergi, if you could help me. La Central Nacional es una compañía activa desde 1886. We have a slide there. Perfect. Desde 1886 representa la venta, distribución y comercialización muy compleja en esta industria del papel. A la fecha, Central Nacional maneja más de 7 millones de toneladas anuales en productos para la industria. Esto significa 6 billones de dólares que se facturan anualmente. Esta es la fortaleza que podemos ofrecerles en el apoyo financiero de todas sus importaciones de papeles. Pues bien, acérquese a nosotros en el tema de importación de papeles, no solo papeles reciclados, vírgenes, pero también cartones, papeles especializados como los que produce Mondi, que vamos a escuchar. Agradecemos su presencia, su tiempo y esperando que esta videoconferencia sea de mucha utilidad, quiero presentarles a los ponentes de esta conferencia. Luis Mora es economista con 3 años de experiencia en la dirección financiera de Airbus Militar y 30 años de experiencia en la venta de papeles para la producción de cartón corrugado, principalmente papeles vírgenes como los craft blancos y marrones, así como papeles mediums y semiquímicos. Sergi Luzán se graduó con un doctorado en Química Física de la Universidad de Umeå, Suecia. Sergi trabaja como jefe de servicios técnicos de ventas en Mondi Container Board. Es responsable de manejar las quejas sobre la calidad del producto, brindar a los clientes soporte técnico durante el proceso de conversión del papel y está involucrado en varios proyectos de desarrollo de productos en Mondi. Démosles la bienvenida. Thank you, Sergi.
Buenos días a todos los participantes en este webinar desde los países latinoamericanos y buenas tardes desde aquellos que lo hagan desde España. Bien, Mondi es una compañía multinacional con participación y con implantación en prácticamente todos los continentes. Dentro de nuestra división de papeles para corrugado, tenemos fábricas en Sudáfrica que producen kraftliner blanco y kraftliner marrón, y en Europa, en Polonia, donde producimos papeles reciclados y kraftliner y semiquímicos, en Finlandia, donde producimos el papel Powerflut semiquímico, en Steti, en la República Checa, donde producimos papeles semikraft y papeles reciclados, y en Rusia, en nuestra fábrica de Syktyvkar, donde producimos kraftliner blanco. Nuestros papeles para corrugado están divididos en función del uso final que se hagan por los kraftliner blancos para el empaque de productos como alimentos, productos agrícolas o cosméticos, el craft café para todo tema, cualquier empaque electrónico, componentes de automoción, agricultura. Los semiquímicos, que serían para uso para el empaque agrícola, con diferentes usos para larga distancia o para resistencia al contacto con el agua, y los papeles reciclados, que es una alternativa ecológica y más barata para los papeles vírgenes. Y sin más, doy paso a mi compañero Sergei Luzan, que nos hablará sobre las cajas de empaque para corrugado de altas prestaciones. Gracias.
Good morning or good afternoon, colleagues. If you are joining us from Latin America or from Europe, I'm very happy that you are today with us, that you found time to join our webinar. I hope you will find it useful. Also, big thanks to AMEXICCOR for giving us the opportunity to present this material to you. So today I will speak about the raw materials for boxes. And explain you what should be taken into consideration when designing the box, especially for a difficult supply chain. And here you see an example of one difficult supply chain, in particular in fruit and vegetable business. So when the fruits are harvested in the south, and then they are transported to the north. That is a normal road for the fruit and vegetable export. So when the fruits are harvested, they put in the boxes, then boxes go in the truck, then truck travels along the road in the dry and hot environment. Then afterwards, the fruits and vegetables, they get on the ship where the environmental conditions are already different. It's humid. Then it arrives to the port of destination. And again, the fruit and vegetables, they're reloaded in the truck. And there, the conditions are again different. So it's snow, icy, and also cold. And then at the end, when the fruits and vegetables arrive to the end place, the final destination, we would like to avoid the situation as shown here, when the boxes are simply too weak and they cannot withstand this long and also difficult supply chain. So we want to ensure that when the fruits and vegetables, when they arrive to the final point of destination, that the fruits and vegetables are intact, they are not damaged, and they are as good as when they were harvested. And for that, it is very important to select the proper raw material for the boxes. We already spoke a little bit about the environmental conditions on the example of a supply chain, and here you see a few more examples, how different and how tough the environmental conditions can be in the storage and the transport. So for instance, on this picture here, you see an example of the cooled warehouse. And just after the moment when the forklift have entered the area from the outside. So the forklifts have brought some warm air inside, and immediately there is a water condensation happening in the air, and this condensate is getting onto the boxes, and as a result, being absorbed by boxes, it will also weaken the boxes, and the boxes, as we will see later, will lose its strength. The other example is shown here. The example is taken in Poland, but it can also be quite similar in any other place around the world. You see how the relative humidity is changing over time. So here you see the change in relative humidity over a month period, and below you see a zoomed in view on the humidity changing within the week. And you clearly see that you have a change from from night to day and back and forth. So the humidity is constantly changing, constantly oscillating. And that, of course, introduce additional stresses for the packaging. You may think that in the refrigerated container that the conditions are stable there, but it is actually not the case. So if you look at this picture here at the bottom of the slide, you see at temperature and humidity variations inside the refrigerated container. The refrigerated container every 6 or 12 hours has to go through the defrosting cycle when the ice accumulated on the cooling coil has to be melted. And during this defrosting cycle, you see the humidity is jumping in the refrigerated container, and even though the temperature may stay relatively stable inside around 5 degrees, the humidity is still varying there from almost 90 down to 60% relative humidity. So this example just to illustrate you that the stable relative humidity, they are likely happening mainly in the laboratory. In the reality, whether you're speaking about the warehouse, the outside storage, or even the cooled container, you always have some variation in relative humidity. And that is something what we should remember. So when the humidity is changing, we are changing the amount of moisture in the air. And as we change the amount of moisture in the air, then paper has to come into equilibrium with the surrounding environment. So if the relative humidity goes up, paper starts to absorb some humidity, the moisture content in paper is increasing. And what is happening, if the moisture content in paper is increasing, then the strength of paper is going down. So here you see an example for brown kraftliner, which shows you how the compression strength is changing with increase in moisture content. So as the moisture content goes up, the compression strength goes down. And as a rule of thumb, you can remember that with the increase of moisture content in paper by 1%, the compression strength of paper is going down by on average 8%. On the right-hand side, you see an example how the tensile properties of paper is changing with increasing or decreasing relative humidity. So if in compression we are compressing the paper, in a tensile test we are stretching the paper. So the more steep line you have, the more stiff paper is. And the longer line you have, the more flexible paper is. So as you see, when the humidity is increasing, then this line becomes less steep, but it becomes longer. So it means that when the relative humidity of the air is increasing, the paper is becoming less stiff, but more flexible. So the relative humidity of the air affects the moisture content of the paper, and it also will affect the strength of paper and strength of boxes. So of course, we would like to understand what is actually the best paper which will resist the absorption of water. And different people can do different tests to evaluate which paper is actually better. Some people doing a COP test. In a COP test, you put some water on a paper surface, and you are measuring how much water the paper is absorbing over a given time period, whether it is 60 seconds or 120 seconds or even 1,800 seconds. Then, at least in Europe, some people are doing the test called FEFCO09 test, where they take a piece of corrugated board, they put it on a hook, and then the whole construction is immersed into the water. Then you make two cuts, and on the bottom you hang a weight, and then you measure the time, how long it takes for corrugated board to break. Actually, this test is primarily designed to evaluate not the paper strength and not the board strength, but actually the strength of the glue line, and to look actually at the quality of gluing liner between liner and fluting. But still, some people are also comparing paper based on this test. Then you have a standard destructive paper strength test, such as CCT test for fluting, or CMT test for fluting, or SCT compression test for liner, tensile stiffness test for liner, or a bursting strength. So these are quite standard tests, and normally you can do them at standard humidity conditions, 50% relative humidity, but also some people, they are using a high humidity condition, so they're conditioning the paper at 90% relative humidity, and then afterwards they're testing these tests, and then they see how big is the drop in the values of the strength after conditioning at 90% relative humidity. And we will speak about it a little bit in more details on the further slides. So why are papers different? The papers are different mainly because the raw materials for the papers are also different. There are four main types of the raw material for containerboard grades. There are a softwood or long fibers, which are cooked by a chemical process, also called as a craft process. Then there are a hardwood short fibers, also cooked by the chemical process, craft process. Then there are fibers which are cooked by chemical-mechanical process, or a combination of chemical treatment and mechanical impact. And then there are recycled fibers, which are secondary fibers. And if you look at different properties of paper, the main properties I would characterize as tensile properties, which is showing you how well paper resists stretching. Then compression, which shows you how well paper resists compressing. Then bulk, showing you how thick paper is.
Perdón, quisiera hacer una pausa para todas las personas que no han encontrado el botón de traducción, porque no están entrando al español y están preguntando cómo entrar.
Excuse me, may I continue? Or...
Les comparto nuevamente la pantalla en donde podrán ver dónde está esa opción. Permítanme un segundo.
Okay, I will wait.
Pueden ocupar en la sección de interpretación, seleccionen el idioma español y ahí podrán escuchar a nuestro traductor simultáneo.
Gracias, Pedro.
Continuamos, Sergio.
I'll share my slides now. Yeah, so I stop at bulk. So the bulk is showing you how a thick or bulky paper is for a given grammage. Then you have a creep property, and we will speak quite a lot about this property in this presentation. So the creep is showing you how well the paper is resisting the compression under the constant load over the time. Then you have formation, which is quite important for printing. And then you have also dimensional stability, which is showing you how much paper is changing dimension when paper absorbs or releases water. And I just put a circle around the most prominent feature of every type of fibers. So for instance, for softwood craft fibers or chemical long, they are particularly good in the tensile properties and creep properties. The hardwood chemical or hardwood craft fibers, they are very good when it comes to formation. That's why, for instance, when you produce white top craft liners, normally you put a white hardwood fibers on the top and long chemical fibers on the bottom to get a good combination of strength properties and formation. Chemical-mechanical fibers, they are very good in compression, bulk, and also in creep. That's why these properties are very important for the medium. That's why normally the semi-chemical flutings are considered as one of the most suitable materials for applications where you need very high creep or very high compression resistance. And recycled fibers, they are relatively cheap and economical, but they are of course quite weak, and the only benefit which they have is that this paper is shrinking or expanding the least when it's subjected to different environmental conditions, because the recycled fibers, they already hornified, so they are not absorbing or releasing so much moisture. So as you have seen here, different type of fibers, they have different strong points. And therefore, if you combine different fibers together, you may also fine-tune the properties of the paper. So fibers is one side, but on another side, we have also the paper making process where we can affect the properties of the paper. And in particular, if we speak about the resistance to water absorption, there we have an opportunity to add some water-resistant chemicals, polymers, either at the headbox at the beginning of the process, or if the paper machine is equipped with a special equipment called size press, where you can apply on the surface of paper a thin layer of different kind of chemicals, polymers, then we can also apply some polymers on the surface of the paper at the size press. And this is actually how some of papers with very high water resistance are produced. They're actually produced using the size press and using the special water repellent chemicals, which are applied on the surface of paper with a size press. Here you have an example of two different type of craft liners. So one craft liner, I call it a regular craft liner, which was produced without this special treatment with a size press on the surface, and another craft liner, which I call the special craft liner, where special water repellent polymers were put on the surface. And so these two types of paper, they are compared after the surface of paper was subjected for 2 hours in direct contact with water. And after 2 hours, then we tested the tensile stiffness of paper. So basically we stretched the paper until it broke. And we also tested the burst properties of paper. So you see that the orange column here represents the special treated craft liner, and the pale yellow color represents the regular craft liner. You see that the special craft liner, due to higher water resistant properties, it absorbed less water, and therefore it could retain a substantially higher strength compared to regular craft liners. So depending on the parameter, the paper retained up to 50% higher strength, which also at the end will translate in the higher strength of the boxes. And in some cases, this special treatment at the paper machine and the special craft liner could be quite a viable alternative to the wax application at the corrugator. So here I'm not speaking about very extreme cases, very extreme application of wax, where you simply immerse the piece of corrugated board into the wax, but I'm speaking more about the soft application where you apply some water repellent wax at the corrugator. So you can basically achieve quite a similar effect with this special craftliner, because this step of application is basically taking back to the paper machine, and therefore you don't need to use any paraffin at the corrugator, therefore avoiding some paraffin, and also adding to the, which is quite important now, to sustainable image of your brand, of your company. Also, you have no issues with recycling this material. And of course, as you are removing the application of wax at the corrugator, you can also run the corrugated faster. And as you have no wax on the surface, the printability of the corrugated board is also not affected. So I'm not saying that for all cases you can use a special kraftliners and replace wax in all the cases, but in quite many cases you can actually do so. However, before we spoke about direct contact with water, I was telling you before that some of the people are trying to evaluate how good the paper is for the humid conditions by conditioning the paper at 90% relative humidity and then testing the paper either for SCT or for burst, depending on the test required. And quite interestingly, we also did a lot of tests like that, and we found out that actually the behavior of papers is quite similar. So if we took different kraftliners produced by different suppliers on different paper machines, we conditioned them for 24 hours at 90% relative humidity, and then we tested the SCT and we compared how much the SCT drops after conditioning compared to original values. And we noticed that on average, the drop is actually close to 50%. So of course, the starting point can be different because different papers, they have different strength, but the drop is quite similar. So the drop is around 50%. And also for burst, we also noticed that also the burst is on average dropping by 20 to 25%. Why the burst is dropping less compared to SCT? If you remember, I was mentioning you on one of the previous slides that when paper absorbs water, it becomes more flexible, more stretching. And the burst is a combination of a resistance of paper to stretching. So basically, if the paper becomes weaker but more stretchable, then the burst is dropping not to the same extent as SCT. But my key message here is that actually the test of conditioning paper at high humidity and testing afterwards, it may show you some difference, but the differences between different papers would not be so drastical. The drop in the performance would be quite similar, about 50% for the SCT and about 20 to 30% for burst. So far we have only spoken about the tests which are performed immediately, so-called peak load resistance. Whether we do this test at 50% relative humidity or at 90% relative humidity, in real life, we never have static conditions. And therefore this test, even though they can be done relatively quickly, if we imagine that on this scale we put how well the tests are replicating the real life conditions, the peak load tests are actually relatively far from the real life conditions. Yes, they can be done quickly, but they are relatively far from the real life. Therefore, the suppliers of paper and the producers of paper were looking for the other ways to look at the paper resistance. And one of the tests which was developed was so-called the CCT test, where the paper was subjected to the constant load at 90% relative humidity and then you are measuring how long actually the paper is resisting this load. And normally you would report the load which paper can hold for 10 days. And this test, of course, shows you a bit better the link between the real life conditions and the testing. But then the next step was done to move to the so-called CCT 15% test, where instead of having a constant relative humidity conditions, the relative humidity was changing from 50 to 90% relative humidity. And therefore, this test was even closer to the real life. Of course, in the ideal conditions, you would like to look at the test where you don't only test, you don't only change the relative humidity, but you also change the temperature, and ideally you can also change the load. But this test is not yet existing. So for now, the best test which can mimic the real life condition is this CCT 15% test, where you can subject the paper to the constant load and change the relative humidity conditions and see how long the box or the paper will survive. So, and how long the paper will survive will depend on how well the paper performs in the creep testing, or how good the paper is has a creep property. But what is actually creep? Creep is a tendency of material to deformate under constant load. So you can look at this very simple example where you have a tree and then you put some weight on the branch of a tree. So with the time, the branch will deformate. And the same applies also to paper and to corrugated board and also to boxes, as all those materials, they actually come from wood. They are made from wood. And on this slide, you can see that actually this is the case. On this graph, you see how well the paper is or resisting, or how much the paper is deformating under constant load. So on the XX, you have time. On the XY, you have a deformation. So you see that if you keep the same load over time, paper will deform more and more until at some point it will just collapse. But what interestingly, you can see here that if you use a change in relative humidity condition, in this case, changing them from 35 to 90%, then the failure happens much faster. So here you have a logarithmic scale. So this difference here is actually much bigger than it looks visually. So the paper is collapsing, and the same applies to the boxes at changing relative humidity faster than it will do at a constant relative humidity condition. And also interestingly to look at this plot, because here you see how the lifetime of the box depends on how much the humidity is changing, or how many humidity cycles you have per day. So in the basic case where you have no changes in humidity, let's say the box can survive for 50 days. But once you introduce one cycle per day, then the lifetime of a box will go from 50 days down to 10 days. And then if you will further reduce, or let's say then depending on how many cycles a day you have, this lifetime will be different. So interestingly, if you have 2 cycles of changing humidity per day, the lifetime of the box will be actually a little bit higher than for 1 cycle a day. But for half a cycle per day, the lifetime will be even lower. So you may have a question, why actually if we have 2 cycles per day, the performance is better than if you have 1 cycle a day? And the answer to this question is that it actually takes some time for the humidity to penetrate through the paper, through the box, and for the box to reach the equilibrium. So if the humidity is changing too fast, then simply, like in this case where you had 2 cycles of humidity changes per day, the boxes do not get enough time to reach the equilibrium. Therefore, the effect of changing humidity is not as strong as where you have a bit slower change in humidity, because there the boxes really can reach the equilibrium, and by cycling this humidity, the boxes are collapsing much faster. Then you may ask, but what is actually the theory behind the creep? And behind the creep, we have two theories. So one theory is on the fiber level. The fibers in the paper, they are crossing each other, and they, at this crossing, they are forming the bonding between themselves. And as when the humidity is changing, fibers are either swelling, absorbing water, or releasing the water and shrinking. And the fibers are shrinking much more in the cross direction than they do in the length direction. Therefore, at these crossings, as you are cycling the humidity, some stresses are being built up because fibers are not shrinking the same way. And as you are cycling, these stresses, they are weakening the bonding between the fibers, and they are resulting in the lower strength of paper and the boxes. And the second theory is looking at creep on the boxes, on the level of boxes. So there, let's imagine you have a liner 1 fluting liner 2. So at first you have a normal humidity outside the box, inside the box. And then once the humidity outside the box is increasing, then liner 1 is starting to take to absorb first the humidity. It starts to expand. And the fluting and liner 2, they did not expand yet. As this liner 1 expanded more, it is taking all the load, and therefore it is damaged more. Then, as the humidity is stabilizing all the way across the board, all papers are again having, let's say, the same length. But then when you lower the humidity outside, then again the paper outside starts to shrink first, while inside the box the humidity is still high and the paper is still longer. And then the liner 2 is taking all the load, and therefore it is damaged more than the liner 1. And then as you go in cycles, step by step, you introduce some damages to liner 1, liner 2, liner 1, liner 2, and after some cycles, you get a packaging which is actually collapsing. So let's spend a few more minutes speaking about the creep test itself. So I was telling you before about the CCT10 test, which is done at the static relative humidity condition at 90%. And then this test is telling you what is the load that the fluting, but it can also be the liner, can carry over 10 days. Normally you would make a wave, you can put it in the holder is put under the press, and then there you load the fluting and you measure the time. And for instance, the final purpose for you is to find the relation between the load that you put on the top of the fluting and the lifetime of the fluting. So once you repeat the same test for different loads, you can build this load versus lifetime relation. And then, for instance, if you would like to find out what kind of paper, or you need to pick that will hold, for instance, 10 kilos or 100 newtons for a given time, then you can use this curve to find out. So for instance, in this case, 100 newtons or 10 kilos will be held by the paper for about 70 hours. So you can really understand what would be the lifetime of your paper, what will be the lifetime of the box. Here you have an example of CCT15 test. As you remember, the difference between CCT10 and CCT15 is that CCT15 is conducted at the changing humidity conditions. So you change the humidity from 50 to 90, from 90 to 50, and so on, in a cyclic manner with a step of 3 hours. And then you measure the time until paper is collapsing. On this graph, you can see the behavior of different types of paper in this test. So for instance, the green line and the blue line, they are showing different semi-chemical flutings, whereas this pink line or violet line is showing you the strong recycled fluting. And you see that there is a clear difference. There is a clear difference in the number of days that the semi-chemical fluting can hold the load in reference to recycled fluting. And this difference you may not be able to see if you will conduct just a simple compression test, because in compression test, this paper may have a quite similar performance. So here you have a comparative analysis in the percentage-wise, comparing different type of semi-chemical flutings and recycled flutings. So the higher the bar is, the longer the paper can hold the load in the humid conditions. And then the lower the bar is, the shorter the time is. And you see that on the left-hand side, you have mainly semi-chemical flutings. On the right-hand side, you have mainly recycled flutings. And you see that the differences actually are very large. So the differences are very big between the flutings made from different type of fibers. So when you do a creep test, as I said, you would like to understand how long for each load the paper can hold this load. So you will take one paper grammage, and for this paper grammage, you will put different load on the paper, and you see for how long this load will be held by this paper grammage. And then if you build it in a logarithmic scale, you normally have these nice lines which showing you the relationship between the load and the time. So if you repeat the same test for other grammages, you will have other lines. And why is this information helpful? Again, as I was saying before, if you, for instance, have different paper grammages, and you know that, for instance, you need to hold 20 kilograms meter of material, then you can say, okay, so this paper will hold it for 2 days, but if I go to higher grammage, then maybe this higher grammage will hold this load for 30 days. And therefore, you can understand, depending on how long you would like the paper to hold the load, you understand what kind of grammage of paper you will need. So you can predict the lifetime of your paper, and also as a result, the lifetime of the packaging. What is important to say and underline once again is that the static tests, they quite often don't show you the difference between the papers so well, as they are not so close reflecting the real life conditions. So on this graph, you see a comparison for different papers, all papers taken in 150 GSM. On the XX, you have the CCT values of these papers, which is a static test. And on the XY, you have a time in days showing you how long this paper will hold the load in the creep test. And you see that especially for strong papers here, you have quite similar performance when it comes to CCT, but very different performance when it comes to creep. So if you will test this paper with a static test, they will look to you quite similar. But then if you make a packaging out of this paper and you put it in a supply chain, actually some boxes may collapse quite fast, while some other boxes will hold for much longer. So far I was telling you about the tests done for papers, but obviously the same tests can be also replicated for corrugated board and also for boxes. So here, for instance, you have an example already of the corrugated board. You have 3 lines which represent you the resistance of corrugated board to load at constant load. And this line represents you the corrugated board made with 2 times kraftliner 200 GSM and 1 time recycled medium 170 GSM. And these 2 lines, they show you the corrugated board, which is made out of using 2 times semi-chemical fluting in 160 GSM. And you clearly see a difference, even though the liners were the same in 2 cases. But if we, for instance, take a 30 kilo as a load that we would like to hold, then the corrugated board made out of with recycled fluting will hold it for maybe 1 day, but the corrugated board made out of semi-chemical fluting using as a medium can hold the load starting up to from 10 days and longer. And therefore, you can see that actually a small change, you can think you just change the core of the corrugated board, but this change may actually have quite a big impact on the lifetime of your box. The natural question you may have is whether liners they will also have such a big impact on the lifetime of the corrugated board and boxes. The answer to this question is yes. Liners also have a big impact, but based on our experience, the fluting has even bigger impact on the lifetime of a box compared to the liners. So how can we test this creep resistance of corrugated board or boxes? Here you have a picture taken in our laboratory where we do these tests. So you have a very big humidity chamber where you can change the humidity, keeping the temperature as stable as possible. You put the stacks of boxes, you load the boxes to different load, and then you measure the time, which shows you at which time the boxes are collapsing depending on the load. And then you can again build the same relationship between the time and the load. And then for this box, you can quite precisely predict how long the box will hold a given load in the supply chain. Of course, here you can do the prediction of the box lifetime, but you can also do the comparative analysis between different types of boxes. Depending on what kind of tests you will do, you need different amount of samples. So for instance, if you are doing just a comparative testing between different type of recipes, then even 5 to 10 boxes is enough. However, if you would like to really build this load versus lifetime curve, then you need up to 50 boxes per 1 recipe. But in principle, it is possible to predict the lifetime of a box. Also very interesting that depending on how strong the boxes is, there are also different behavior in creep. So on this graph here, you see how the boxes with different BCT values, so how much load they can carry for 20 days. And you see that in the mid range of BCT values, for the same BCT, the boxes are showing quite large differences in terms how much load they can hold over the time. So actually, you can reach similar BCT value with different raw material, but it does not mean that the boxes will behave the same way in the supply chain. But when you go to very strong boxes with very high BCT values, then actually these differences between different recipes are actually getting quite smaller in terms of creep. And we think it is happening so because the box is reaching its structural limit. So to say, for a given box design, you already reach kind of a limit where the selection of raw material doesn't impact so much already the load carrying capability of a box. So basically, the weak point of the box comes not actually from the raw material, but from the box design itself. And here is another example. Again, we tested two different types of corrugated boards and two different types of boxes, which had quite a similar grammage, 450 or 460 GSM. Interestingly, the recipe A had lower ECT values and also quite lower BCT values. But then when we tested the creep performance, so creep performance on the corrugated board sample, then actually this creep performance was the opposite. So you see that for a regular ECT test, the A recipe had a lower ECT values, but for the creep test under there, keeping the corrugated board under constant load, actually the A recipe was even stronger. And the same tendency we saw also when we tested the boxes at this constant load conditions. We saw that despite different BCT values, the recipe A and B, they were quite similar when it comes to the load carrying capability. So both recipes could hold 22 kilos for 10 days, 18 to 19 kilos for 20 days. And actually the A recipe could hold 18 kilos even longer, about 4 weeks, compared to B recipe, even though the BCT values for A recipe was lower. So the key message here is that the BCT test itself does not show you the full picture. Your box may have a higher BCT values, but it does not necessarily mean that it will have a longer lifetime in the supply chain. And closing my presentation, I would like to summarize and to put here the key message that I would like you to remember. So when you're designing the box, you have to understand your supply chain conditions. So if you know that in a supply chain there is a high risk that there would be a direct contact with the water, then it may make sense to consider the special kraftliner which are treated on the surface with water repellent chemicals. Of course, you can reach this effect also if you apply the wax at the corrugator, but then you should also consider the whole picture, considering that if you use special kraftliners versus wax application, there are some benefits as we discussed. You can run special kraftliners faster, you get a better printing at the end, and also you get a more sustainable image. Speaking about the conditioning at 90%, it is a valid test to compare the papers, but you should also remember, as I showed you earlier, that actually the drop in strength is quite comparable for different papers and even for different grades. Interestingly, this 50% drop in SCT values, which I was telling you, it applies not only for kraftliners, which are sized papers, but it also, for instance, applies for papers made out of other raw materials like testliners, recycled papers. So it's not really so much specific for a type of fibers. So as the test after conditioning at 90% does not give you the full picture and the clear differentiation, if you want to really understand which paper is better for which conditions, then you need to look at the creep performance and to subject the paper to the constant load and measure the lifetime under the constant load. And also looking at standard properties of paper and corrugated board, such as SCT for paper, ECT for corrugated board, and BCT for boxes, of course gives you the understanding about how strong the box is, but it does not necessarily tells you how well the box will perform in your supply chain. Therefore, if you would like to get the full picture, please test your boxes, also test your boxes with a creep testing and the constant load. And if you do not have the equipment, and if you would like to get assistance, we, of course, offer you our facility where we can test the creep on paper, corrugated board, and boxes. And we, of course, can help you not only with testing, but we can also give you advice on the box design, advising you what would be the best selection for your particular supply chain. So at this point, I would like to close my presentation and then pass the word back to Norma. And then I'm also looking forward to our Q&A session, which will take place basically soon at the end of our presentation. Thank you very much. And Norma, I'm passing the word once again to you. Norma.
Sergey, muchas gracias por toda la información, toda muy útil. Tenemos varias preguntas aquí que son interesantes. Voy a pasar a leer algunas para que nos puedas ayudar. El recubrimiento de los papeles especiales que hablabas, ¿puede sustituir a los aditivos como es el caso del Nickelman?
Yes, correct, Norma. It's a good question, and that's what I exactly meant when I told you that for some mild application of chemicals at the corrugator, these special papers, they could be a viable alternative. So the answer is yes. They can be an alternative for the application of, for example, Michelman at the corrugator.
Muy bien, también tenemos esta otra pregunta. ¿Cuáles son los valores de ST para cada papel y su correlación con ST?
So when we speak about the SCT values, of course, the higher grammage of paper you have, the higher SCT values you get. Therefore, if you would like to compare the papers, especially in different grammages or especially with different type of raw materials, we quite often look at the indexes. So index means that you take the absolute value of SCT and then you divide it by the paper grammage. So if you look at the SCT indexes, and for example, you speak about kraft liners, then kraft liners will have the SCT index on a level of about 20. If you speak about test liners or recycled papers, then depending on the quality of recycled paper, the SCT indexes could be in a range of from 13 up to 16, 17. If you speak about semi-chemical flutings, because semi-chemical fibers are very stiff, there the SCT index can go as high as 25 or even 28. So if you would speak purely about SCT values and you will arrange the papers, then you will have the highest SCT indexes for the chemical flutings, followed by the kraft liners, and followed by the recycled papers, test liners or waste-based flutings. And the second part of the question was, can you please repeat the second part of the question? Because I think I replied only to the first one now.
¿Cuál es la correlación de ST con ST? Y también la misma pregunta, una correlación entre valores de ST y BCT.
So speaking about the correlation between SCT and ECT values, the correlations are quite well defined. So normally you have a coefficient, and then you have to sum up the SCT contribution coming from every layer. SCT of liner 1, SCT of liner 2, then you have to take SCT of the fluting, multiply it by the take-up factor specific for their wave, and that would give you the ECT values. The interesting point here is that the coefficient is slightly different for virgin and for recycled papers. And therefore, if, for example, you take the paper with the same SCT values, virgin and recycled, then the virgin paper will give you slightly higher ECT values. So the principle is the same for virgin and recycled fibers, but the coefficient is a little bit different. And that is, if you would like to be very precise in estimating the ECT values, then you have to use a little bit different coefficients for virgin and for recycled fibers. Now, speaking about BCT, the formula which we are always referring is McKee formula, a quite known McKee formula, where the BCT is calculated as a combination of contribution from the ECT of the corrugated board and from bending stiffness of the corrugated board and from the box perimeter. And this is the formula which was developed already back in the 60s, last century, but this formula is still working quite well, I would say. And with this formula, you can predict the BCT values of the box with a precision of about 10%, at least based on my experience.
Tenemos una pregunta muy específica. Durante una prueba de BCT, ¿a qué se debe que la platina del equipo siga comprimiendo una caja aun cuando ya se terminó de realizar la prueba? Es decir, aun cuando ya marcó un resultado de resistencia.
This is a good question. If I understand it correctly, the question is when you do a BCT test, a regular BCT test, of course, you compress the box. And as you compress the box, the deformation goes up, so as the load goes up. Then you reach the resistance goes down, but the platen continues to move. To be honest, I mean, there must be certain settings in the machine which tells you at which point to terminate the test. But obviously, I know what you mean. So the curve goes down, but what you're interested at this highest point, actually. Why the platen continues to go down after you reach the maximum? I believe maybe I'm just guessing now. Maybe you simply need to have this clear peak that you understand it was a peak, because maybe if you terminate exactly there, then you don't know. Maybe you had a small drop and then continue to grow. That is my interpretation of this question. But I hope that I also did not misunderstand the question. I hope that I understood it correctly.
¿Por qué existe tanta diferencia en distintos papeles semiquímicos al ser sometidos a humedad, a mismo gramaje y distintos proveedores? ¿Qué dato técnico deberíamos analizar en la ficha técnica?
It's a good question. The technical data sheets, as they are designed now, they are showing mainly and only the parameters which were tested at the so-called the peak load parameters. As I was telling you before, you remember this chart where you had the test, how close this test replicates the reality. And these peak tests, which are shown in technical data sheets, they are, of course, allowing you to understand which paper is stronger, which paper is weaker, but it is not really giving you very clear a link to the real conditions. Therefore, you can of course use the properties such as SCT for liners or RCT liners, or as CCT for flutings, or CMT for flutings, but with a clear understanding that you only see, let's say, half of the picture. If you want to see the full picture, only from technical data sheets, you will not probably see it. That's why on Mondi side, we started to introduce actually this creep parameter into our technical data sheets. So if you, for example, look at Mondi technical data sheets, you will see that together with this standard peak load parameters, we also show the creep resistance of paper. So we started with semi-chemical flutings. We show it now for semi-chemical flutings, but then we also will roll it out for liners at a later stage. Of course, it takes some time before industry will follow this trend. In this case, we are the first ones together with one more company which is starting to show this properties technical data sheets. But I believe at some point it will come to this point that we will see more and more suppliers showing this creep resistance of paper also in the technical data sheets. But for now, to answer the question in short, for now, I suggest if you're comparing the papers and if you're looking for the compression strength, look at SCT. If you are looking more at the bending stiffness of the corrugated board, look at tensile properties of paper. And if you need burst of the corrugated board, then of course you need to look at the burst of the papers which you are going to use.
Fantástico. Los papeles semiquímicos han aumentado sus valores de porosidad en Gurley. ¿Esto influye para corrugar? ¿Y cuánto sería un valor máximo?
So actually, I think that it's true. The porosity of semi-chemical fluting is changing. It is increasing if you speak in terms of Gurley seconds, but actually the Gurley seconds and the porosities, they are in the reverse trend. So the higher the number of Gurley seconds means that the paper is less porous. So nowadays, semi-chemical flutings become stronger and stronger. And one of the reasons how they become stronger and stronger, because the paper supply producers, they invest in the special shoe presses in the press sections. So basically they are pressing the fibers much stronger than it was done before. And therefore the paper gets more close structure and it gets more closed. So the porosity of paper is going down, which means higher Gurley values. Speaking about the highest acceptable values, I would say what we see on the market, the values can go up to 200 or slightly even above seconds of Gurley for the paper, which is high, but still you can run this paper at the corrugator. The key here as well is, despite the closed surface, how well the paper is absorbing the glue. And here, porosity is showing you only one side. The other side, the other test which you can use to understand how easy the paper will accept the glue is so-called a drop test, for example, where you put a drop of water on the paper surface, and then you measure how fast the drop of water will be absorbed by the fluting. And here, speaking about this drop test, as an indication, the good level is about 40 seconds. Yeah. So to answer the question, yes, we notice that the porosity of paper is changing for semi-chemical flutings. The paper becomes more closed. The reason behind because of changing technology at the paper machine. Difficult to say what is the critical level of this porosity. On my experience, I can say even 200 seconds you can still run at the corrugator. And the other message is you should also look not only at the Gurley, but also at the other properties of paper, which will describe you how well paper absorbs glue.
Gracias. Quiero recordarles a todas las personas que están participando que tenemos una encuesta abierta y que nos gustaría mucho que nos ayudaran a contestarla. También les quiero mencionar que conforme van llegando las preguntas, se están leyendo y se nos están juntando muchas preguntas que es posible que no podamos responder inmediatamente, pero nos las vamos a llevar y por supuesto vamos a darles respuesta individualmente a cada pregunta. Voy a leer otra pregunta. Dice, ¿por qué no vemos un análisis de CMT para el desgaste que existe en la pérdida de calibre? Solo veo SCT como un único predictor de BCT.
Correct. Also very good question. So CMT of the fluting is also important, but CMT of fluting has very good correlation with the FCT of corrugated board. And FCT of corrugated board shows you how well the board can maintain its structural integrity. So when you press the board, when you crush it, it shows you how well it actually resists the crushing. So the CMT doesn't have a direct impact on the BCT of the box, because it shows you how well the board can hold the caliper, but it has indirect impact. So if the corrugated board has very low FCT values and the fluting has very low CMT values, then the board will be very easy to crush, either in converting or at the corrugator. And as you crush corrugated board, you have a loss of caliper. Loss of caliper immediately results in loss of bending stiffness of corrugated board, and the loss of bending stiffness immediately has an impact on the loss of the BCT. So to answer the question, CMT of fluting and FCT of corrugated board, they are important parameters which do not have a direct impact on the BCT of the corrugated box, but they have indirect impact on the BCT. I hope I managed to answer this question.
Gracias, Sergey. Pedro, quisiéramos saber si estamos a tiempo para seguir con más preguntas. Son casi, pues, cuarto después de la hora. Déjanos saber.
Gracias, Norma. Sí, todavía hay unos minutos. Usualmente la sesión dura hora y media, justamente porque hay muchas inquietudes, preguntas de los industriales. Hoy tuvimos más de 255 asistentes de manera simultánea, más los que nos siguieron por redes sociales. Y sí, se están desbordando las preguntas, pero con mucho gusto podemos continuar unos minutos más. Sin embargo, me gustaría aprovechar el momento para escuchar un poco sobre lo que Central National nos puede ofrecer a la industria. Han preguntado sobre este acompañamiento que pueden ofrecer. Si nos puedes comentar, por favor.
Claro, por supuesto. Mira, Central Nacional es una empresa con una vida muy larga. Sergey, yo creo que tienes una ficha, un mapa, simplemente para mostrar a nuestros amigos dónde estamos. Si la puedes poner, me ayudaría mucho. Pues bueno, Central Nacional tiene aproximadamente 30 distintas oficinas a lo largo del globo terráqueo. Y esto nos da una ayuda de network muy interesante, porque podemos ofrecer papeles de distintas procedencias con distintas fibras, que es algo muy interesante para quien quiera iniciar nuevos proyectos. Una de las cosas formidables del Grupo de Central Nacional es que tenemos personal bilingüe que a lo largo de todo el proceso de desarrollo, de consulta, de seguimiento de órdenes, puede perfectamente interactuar en español. Y así que, pues, la parte del lenguaje no es ningún problema. Creemos que nuestras relaciones con los molinos son muy cercanas, son de mucha cooperación y siempre estamos abiertos a atender a todos nuestros clientes en todos los temas técnicos y de apoyo para guiarlos cómo proceder con distintos materiales. Así que pues creo que son partes fundamentales del servicio. Cualquier duda en cuanto a papeles de importación, estamos para servirles. Y pues si quieres, continúo leyendo algunas preguntas más.
Sí, por favor. Tuvimos participación de 15 países que se registraron y bueno, hay preguntas de todo tipo. Entonces, para adelante, por favor.
Okay. Sergey, varias preguntas más, abusando del tiempo de muchos de nuestros participantes. En el laboratorio, ¿cómo sumas el medio de transporte a la resistencia? Ya que solamente estamos midiendo las humedades relativas.
I think that the question is connected to the lab that we had, that I show on the slide, where we test the stacks of boxes at different relative humidity. I mean, there we look at the time, and we obviously the boxes are under compression all the time. So if you have a pallet, it will be under compression, whether it is standing in a warehouse or whether it is transported by the truck. So that is staying the same, and that's what we are replicating in our chamber. The humidity, as we have seen before, is also changing, whether we have a pallet standing in the truck or even in the refrigerator. And that we're also including. So we have a factor of time, load, and the humidity. What we don't include in our testing is, of course, this effect of vibration. Because when you have a transportation, whether you transport your pallet by the sea or by the truck or by the rail, you always have some vibrations. And the vibrations, we did not cover them at all here, but vibrations, they of course also have an impact on the lifetime of a box. And that we don't include here. But there are, of course, special equipments which allow you to also test how well the boxes resist vibration. But simply, we did not put it there because then it becomes too complex. It's still very difficult to fit a special vibration tool in the chamber with high humidity. So it can be tested separately, but for time being, it cannot be tested in this humidity chamber. So to answer the question, we do consider to some extent the transport lag if we don't look at the factor of vibration. I hope I managed to a little bit answer this question.
Creo que sí, Sergey, y también para recordar a todos que el laboratorio de Mondi está abierto a todos nuestros clientes en el momento en el que lo requieran.
Correct, because it's also interesting for us. When we are helping you, we're also gaining the knowledge, and then we are able to help you even more. This is interesting studying for us as well. So we are interested to help you, and by helping you, we're also learning all the time. So it's a beneficial win-win cooperation, I would say.
Así es. Los papeles Aqua de Mondi tienen valores superiores de SCT de papeles convencionales del mismo gramaje.
Also a good question. If we speak about Aqua and the ECT values, you have to differentiate how you, after, when or how you test the ECT values. If you speak about the ECT values tested at normal conditions, 50% relative humidity, then the ECT values of the board made out of Aqua will be quite similar to the ECT values of the board made out of regular kraftliner. But if the board made out of, or if the board comes in direct contact with water, then as kraftliner Aqua has lower water absorption, then it will retain the strength for longer, and as a result, after direct contact with water, then the corrugated board made out of Aqua paper will have a superior ECT values compared to corrugated board made out of standard kraftliner. So for normal conditions, you would probably not see a difference, but if you will compare the corrugated board after direct contact with water, then yes, definitely you would see a difference.
Ok, tengo algo muy específico nuevamente. Al momento de realizar la prueba de ST, como lo marca la norma TAPI 839, ¿a qué se debe que la placa de compresamiento siga bajando, aun cuando ya dio el resultado? Si esto pasa, ¿no se puede tomar como válida la probeta debido al quiebre que se genera en la parte superior de la misma?
Yeah, again, a good question. I think it is linked a little bit to the question we had before about the BCT test, when the question was why the BCT plate keeps lowering while we already have the peak value. Again, I think this is a question we are reporting for the ECT the maximum compression resistance of the corrugated board. So obviously, once you reach the peak, theoretically you have your answer. But why the plate keeps lowering afterwards? Again, I can only guess, and my guess will be probably similar as in the previous case, that maybe we simply need to understand where the peak is, and if you stop it immediately at the peak, then you may be misled by that. You may think it's a peak, but maybe it's not. Maybe just a bump on the way. That is. But please take my answer as a guess, or as a scientific guess, so to say. So that's I cannot say I know 100% why, but this is my best guess as answer to this question.
Pues tenemos muchas preguntas que prometemos vamos a darle seguimiento, de verdad. Ya me parece que terminamos con el tiempo, así que paso la batuta a Pedro Alcalá para que nos comente.
Muchas gracias, Norma. Muchas gracias, Sergio y Luis. Fue una excelente conferencia, una excelente charla. Nos están llegando a través del chat y de WhatsApp muchas felicitaciones en redes sociales por este contenido tan relevante para la industria. Y pues no me queda más que agradecerles a Grupo Mondi, Luis, Sergio y a Central National, nuestro socio en AMEXICCOR, por esta excelente presentación. Y les cedo la palabra, Luis, si quieres dar un mensaje de despedida para el cierre.
Muchas gracias, Pedro. Realmente ha sido una reunión excelente, aunque la hayamos hecho online. Y yo creo que esto es un comienzo. Yo creo que a esto hay que darle continuidad y, por supuesto, nosotros encantados de ponernos a disposición de AMEXICCOR y de Central National para poder efectuar otro tipo de presentaciones o esta misma más adelante cuando vosotros queráis. Muchas gracias.
Gracias. Sergi, si gustas dirigir algunas palabras de despedida.
I can only join to what was said by you, Pedro, Luis, and Norma. Thank you very much for all people who joined us today, who found time in this not easy time that we are through now to join us today. And I hope that each of you have learned something new and each of you found at least something what could be used in the future. And I also wish you, the most importantly, stay healthy, take care about yourself and your beloved ones. And I hope that we will see each other at one of the next sessions of events organized by AMEXICCOR. Thank you very much.
Gracias, Sergey. Bien, les recuerdo que este material, este contenido, estará disponible en nuestra página de internet y pues también ahí podrán estar consultando las siguientes actividades de nuestro programa de capacitaciones técnicas para industria del cartón corrugado. Norma, te toca cerrar con nuestra sesión.
Gracias, Pedro. Muy entusiasmada por el número de personas que han escuchado. Nuevamente comentarles que en caso de que estén interesados en papeles especiales de este tipo, hay todo un proceso y una serie de recomendaciones que el Grupo Mondi da para correrlos. No estamos solos en esto, así que no tengan dudas en ese aspecto. Y pues nuevamente darles gracias a todos, las gracias y el agradecimiento a AMEXICCOR, al Grupo Mondi, a la sabiduría y experiencia de Sergey por acompañarnos en este tiempo y bueno, pues hasta la próxima. Gracias.
Hasta luego, gracias.